Welcome everyone. In this video lecture, we will solve a GATE 2025 EC question which is based on the diode voltage calculation, and we will use the diode equation for finding the diode voltage calculation. Okay, so the question is an ideal PN junction germanium diode has a reverse saturation current of 10 microampere. So here given the reverse saturation current is 10 microampere at 300 Kelvin. The voltage in volts round off to two decimal places to be applied across the junction to get a forward bias current of 100 milliampere at 300 Kelvin. So here the given thing is, I am writing here the given thing. First of all, there is a diode. Okay, so I am making a diode. Okay, and this one is our germanium diode. Okay, and in the question, an ideal p-n junction germanium diode has a reverse saturation current. Okay, so the reverse saturation current is given. Reverse, I am writing reverse saturation current. Okay, that is our is, you can say it as is, and it is given 10 microampere. Okay, clear. And the temperature is also given, that is our temperature. I'm writing capital T H, what, 300 Kelvin, this one K Kelvin. Okay, so we have to find the voltage in volt. Okay, so the voltage in volt to be applied across the junction to get a forward bias current of 100 milliampere. So we have to find the voltage. Okay, and the given thing is forward bias current. Okay, so I'm writing here forward bias current. Okay, which is basically our, we can say, the id value is given how much, 100 milliampere at 300 kelvin. So no need to write. So we have to find the voltage in volt. Okay, so we have to find the voltage, or we can say the diode voltage, we can say vd, we have to find. Okay, so in question, the given thing is reverse saturation current 100 micro, sorry, 10 microampere. Okay, at temperature 300 Kelvin. So temperature is also 300 Kelvin. Okay, and the voltage in volts we have to find to be applied across the junction. Okay, that is our VD we have to find, and the forward bias current is given 100 milliampere. Okay, 100 milliampere. And in addition to that, the given thing is Boltzmann constant. Boltzmann constant 1.38 into 10 to the minus 23 joule per Kelvin, and the charge of an electron, that is our E, or we can say the Q, is 1.6 into 10 to the power minus 19 coulomb. Okay, so here the thing is that this voltage we have to find voltage across VD, diode VD, and the current is flowing like ID is given. Okay, so as we know, the diode equation can be written as ID equals to Is e to the power Vd by eta Vt minus 1. Okay, where eta, that is our, nothing is given, so ideality factor we have to take it factor. Okay, is our 1. Okay, so the equation will be simply Id equals to Is in between e to the power Vd by Vt minus 1. Now thermal voltage, so Vt, as we know, 26 millivolt. Okay, nearly 26 millivolt, but we have to find. Okay, because we have to find the, for a particular temperature 300 Kelvin. Okay, Vd is required. So first of all, we will go for the Vt calculation. Okay, that is our thermal voltage. Id is the diode current, Is reverse saturation current, Vd is the voltage across the diode, eta ideality factor, and Vt is the thermal voltage. So first we will find the value of what, Vt. Okay, that is our thermal voltage. So thermal voltage, that is our Vt, is nothing but simply Boltzmann's constant K, Kt by Q. Okay, this one is the formula for the Vt, thermal voltage Kt by Q. So now this can be written as what? K is 1.38 into 10 to the power minus 23 joule per Kelvin. Okay, and temperature is 300 Kelvin. So I am writing everything. And Q in charge, that is our E value, 1.6 into 10 to the power minus 19 coulomb. Okay, so this Kelvin will be cancelled out. And if we solve, so the Vt value, one can write 1.38 into 300 into 10 to the minus 3, and this way 10 to the minus 9. So it should be 10 to the power minus 4 divided by 1.6. Is it okay? Simple calculation is there. So if we solve this one, if we solve overall this term, it will come nearly 25.86 what millivolt. Okay, millivolt. So Vt value, if we solve, it will come nearly 25.86 millivolt. So this one is the thermal voltage calculation. If we solve, definitely we will give it. It will come 25.86. I have already calculated, so I am directly writing. Okay. Now we have to write the formula. So now we have to write ID equals to IS e to the power Vd by Vt minus 1. Okay. Now ID value is given 100 milliampere. So one can write 100 into 10 to the power minus 3. And this one IS is also given 10 micro. So 10 into 10 to the power minus 6. And Vd we have to find. So we have to write as it is. And Vt is 25.86 milli. So or 10 to the power minus 3 you can write. Okay. Let it write into 10 to the power minus 3 minus 1. Okay, then we have to solve this one. So here 10 to the minus 3. So if we solve this one, this will be cancelled out. 10 to the power minus 2 divided by 10 to the power minus 6 equals to e to the power Vd by 25.86 into 10 to the power minus 3 minus 1. Okay, then again what we can write, if we solve this one, it will be 10 to the power 4. Simple calculation is there. Then e to the power Vd upon 25.86 into 10 to the power minus 3 minus 1. Okay, so now we will have to solve. So 10 to the power 4 means 1 2 3 4 plus 1 will be there. Okay, then e to the power Vd by 25.86 into 10 to the power minus 3. So it should be 1 double triple 0 1 e to the power 25 point. Simple calculation is there. In this problem we have to test our calculation. Then after we have to take natural log on both sides. So it should be ln e base. So it should be Vd by 25.86 into 10 power minus 3. Okay, clear or not? Then if you calculate this one in your calculator, it will be 9.210 equals to Vd by 25.86 into 10 to the power minus 3. Then after, if we calculate Vd, so it should be 9.210 into 25.86 into 10 to the power minus 3. Okay, 9.210 and 10 to the power minus 3. Okay, so if we solve this one, it will nearly come to 38.18 milli 10 to the power minus 3, or simply if you have in the question we have to write in volt, so it should be 0.238 like this. So our answer will be nearly 0.23. So VD value we have calculated, it is just simply our 0.23. Voltage across the germanium diode will be 0.23. So the answer will be 0.23. Okay. This one is simple question, 0.23. Okay, it is in the volt, so no need to worry. It is in the volt. Okay, so that's why we have written like this, 0.23. Okay, so this one is simple one, but we have to careful about the calculation. We have to find the value of what VT, thermal voltage, KT by Q. Okay, then we have find the overall VD by just going step by step. So finally what we will get, this for this video. So this is all about this video. So thank you for watching this video. Thank you.